going on, guys? Let's do this problem right here. So here the question is asking, so first of all we have an equation that 54 gram ice is melting as water and heat of fusion is provided by 6 kilojoule per mole. So this basically means like for 1 moles of ice it needs 6 kilojoules of heat to melt, right? So that's what it representing. Here the question is asking how much heat energy is required to melt 54 grams of ice. So here what we have to do is, first of all we have to convert this gram into mole, right? We have to know how much mole of ice we have, right? So then we have to calculate how much heat energy is required to melt all of those ice. So let's do that right now. So it's going to go from gram to mole, then mole to kilojoule, right? So how can we convert gram to mole? All we have to do is simply divide this one by its molar mass. So we know that molar mass of water, so ice is still water, right, in solid form. So if we divide this one by molar mass of water, that's going to give us the mole. So let's plug the values. So first of all we have 54 grams of water divided by 1 multiplied by, in 1 moles of water, we have 18 grams of H2O. So 18 grams of H2O multiplied by 6 kilojoule per mole. 6 kilojoule per mole, and if you notice, gram cancels and mole cancels. Finally we get the value in kilojoule. So let's calculate this one. So this is 18 times 2 is 36, 18 times 3 is 54, so this is basically 3. So 3 times 6 is 18 kilojoules. So it needs 18 kilojoule of heat to melt all of these 54 grams of ice. So that's what it really means. And let's look at the second question right here. We have a combustion reaction, that's C3H8, that's propane, reacts with oxygen and giving us carbon dioxide and H2O. And if you notice, we have this plus 1200 kilojoule in the right side. So also we don't have the delta H. So it means it's an exothermic reaction. Whenever we have something in right side, it's an exothermic. If you have something in left side, that's endothermic, right? So let's write this one down. So this is exothermic. It means heat is released, right? Exothermic. And the question is asking how much heat energy will be released if 64 grams of O2 react. So before we do that, we have to balance this equation. So whenever we have combustion reaction, we first balance the carbon dioxide, and if you count the carbon in the left side, we have 3. So we balance this one. This is going to be 3 CO2, and also the next thing is water. Here, if you notice, in the left side we have 8 hydrogen, so we have to multiply this water by 4. So this is 4 times 2, 8 hydrogen. Now we have balanced the equation for everything but except oxygen right here. If you look at the right side, we have 6 plus 4, 10 oxygen. Here only have 2, so we have to multiply this one by 5. So that's going to give us 10 moles, 10 oxygen right here. So here we have 1, 5, 3, 4. So from this one we can conclude that if 1 moles of propane react, 1200 kilojoules of energy is released, and if 5 moles of oxygen react, 1200 kilojoules of heat is released, right? So that's what it really means. So here they are asking how much heat energy will be released if 64 grams of O2 react. So first of all we have to know how much mole of oxygen 64 grams contains, right? We know that if 5 moles react, 1200 kilojoule. If 64 gram, we have to know this one in terms of mole. Then only we can determine how many kilojoule is going to release, right? So here again we are going to do the same thing. We are going to convert this gram into mole, then mole into kilojoule, right? So let's take the oxygen right here. So we have 64 grams of O2, 64 grams of O2 divided by 1, and oxygen's molar mass. For 1 oxygen is 16 grams of gram per mole. So here we have 2 oxygen. O2 means 2, right? So 2 is 16 times 2, that's going to be 32. So in 1 moles of O2 we have 32 grams of O2. So 32 grams of O2 multiplied by 1200 kilojoule per 1 moles of O2. So if you notice, mole cancels, gram cancels, finally we will get answer in joule. So let's simplify this one, and here we have 3264. 3264, and here this is 5 mole basically, because if you notice the equation, this is 5 right here. So 5 moles of, if 5 moles of oxygen react, it releases 1200, so this is supposed to be 5. So we have 5, and let's simplify this one. We know that 32 times 2 is 64. This is going to be 2 right here, and 1200. 1200, we can write this one as 12 times 100. So 2 times 12 times 100 divided by 5. So we know that 5 times 20 is 100. So 20 times 12 is going to be 240. 240 times 2 is going to be 480. So 480 kilojoules of heat is released when 64 grams of O2 react, and that's how we do this kind of problems. I hope you guys found this video helpful. See you next time.